table shows the weights of several kittens. Part A. Find the outlier. Well, what is an outlier? An outlier is a data value that is much greater or much less than the other values. So, in our set of kitten weights found in the table, to find the outlier, look for the value that's quite a bit greater or less than all the other values. Can you find it? Sure, 6 8/10. Why? Because it's quite a bit greater than the other data values. Notice that the least value in the table is 2 7/10, but it's not that much less than some of the other values like 2 8/10 or 2 9/10. So 6 8/10 is definitely our outlier. Write that as our answer to part A. Part B. Find the mean with and without the outlier. First, let's find it with. Write the fraction bar and write the sum of all data values and divide by the number of data values. With the outlier, there are 10. Start to simplify by finding the sum. The sum of all the numbers is 33 8/10. When we divide by 10, you have 3 38/100. Now find the mean without the outlier. First, let's mark the outlier in the problem with. The outlier was 6.8, so all we need to do is omit that when we write the sum of terms. Now, the thing is, how many data values do we have without the outlier? Right, there's only 9 without. So now we can find the sum. The sum of all those numbers is 27. When you divide by 9, the answer is 3. So that worked out nice. So once again, with the outlier, we have a mean of 3 38/100, and without the outlier, we have a mean of 3. Part C. Describe how the outlier affects the mean. Look back at the table of values and compare those values to our mean with the outlier, 3 38/100. You should notice that with the outlier, the mean is greater than all the other weights. That is, all the other weights except for the outlier itself, 6 8/10. Without the outlier, the mean better represents the data.